Ada. Hello.
Hello? Can you hear me? Hello? Boleh dengar tak? Boleh dengar tak?
Hello Sakib.
Hello, Sakib.
Easy.
Salam satu Malaysia, Najib. Boleh dengar tak? Boleh dengar tak? Okey, Sylvain, boleh dengar. Okey.
Okay, hello, kita tunggu sikit lagi.
So, let's wait for a couple minutes for the others to join us on this evening lah. So, before we start,
Dengar guys, okay guys. Okay ke cuti Azhar?
yang tengah bercuti tu okey ke? Sebab dah hujung-hujung tahun ni.
16 viewers. Okay, sangat guys. Okay, I think we can start now since it's already 1:32. Okay, Assalamualaikum and a very good afternoon. Welcome to our lunch menu session, and today we are broadcasting live from Kemaman. Thank you for joining us today, and before we go further, don't forget to like, share and follow our Facebook page, and you can also subscribe to our YouTube channel, BNB channel, where we are sharing lots of exciting activities and knowledgeable videos for all of you. Okay, since this is our first time to host this session, let's first introduce ourselves. Okay, my name is Muhammad Hanif bin Jasmi, and I'm the service engineer for Tekong Kemaman branch. And my friend here is Aswadi.
So my name is Muhammad Aswadi. So I am area engineer for Tekong Kemaman branch. So before we start further, so today we are going to continue the topic for the smart controller, and we are going to discuss on features of the device as well as a quick demo on our smart positioning facility and also the diagnostic. So for the first part, I will pass to Hanif to present to you. Okay, Hanif.
Okay, hi. Okay, for today we are going to continue on yesterday's topic of smart valve positioner. And then after this, I will show you a simple demonstration on how our smart positioner works, its features and its diagnostics. Okay, if you had followed us on yesterday's session with Sim, our colleague, inshallah, he had shared with us the overview of the smart product, the fundamentals, the communication protocols, and as well as the evolutions of the diagnostics, which is from the first to the third generations of the diagnostics. And for today, we are going to go a little bit deeper position corresponding to its desired set point or targeted position. Okay, as mentioned by Ayman and by Sim yesterday in their previous session, he has stated an analogy that we can compare the positioner to our brain, and actuator is like our muscle and our hand. Okay, to get along with this, okay. Okay, to get along with this analogy, we can add another element, which is the feedback element, and we can compare it with our sensory organ. Okay, for example, we want to shut off a water tap. Kita nak tutup pipe air from our eyes, which is our sensory organ, in comparison with the feedback mechanism. We will keep turning off the tap water. Pilot pipe kita tutup until we can see that no more water dripping from the water tap. Okay, there. In this case, our final position, final target, final set point, desired set point is to make sure that no more water drips from the water tap, and then we are going to keep turning off the tap until no more water drip. It is the same with our positioner at site or in a control system, where system controller will give a command to the positioner based on the feedback mechanism, whether it is a sensor or transmitter, to move the valve to its desired position. Okay, for next slide. Okay. A smart controller of valve positioner have the unique ability to perform diagnostics and allow user to perform predictive maintenance in a more effective and accurate ways. This is one of the key points that differs a smart positioner from a conventional positioner, so that users have the capability to predict what to do with if there is any problem with the valve or the valve package itself. And then the positioner itself is embedded with a powerful microprocessor, enabling accurate control of valve position by receiving a signal from the control system and the sensors built in the position itself. As what Sim has told us yesterday, he said that a smart positioner will have many type of sensors embedded inside the positioner, so that it can perform measurement of input signal, temperature of the device itself, input pressure, and also the valve control, valve position. Okay, and then next slide. Okay, yesterday Sim has told us many type of key features, but today, since this is only for recap purposes, I'm going to share with you some of the features. One of them is the capability to perform diagnostics that allow user to analyze on the positioners as well as the valve health and condition just from data interpreted from the position itself. For example, our valve controller can communicate with a PC that has been connected to a software, a valve or device management software, and it will be connected directly to the positioner, or it will connect it to the control loop. And this can ensure that we can perform advanced diagnostics. And for the diagnostics, Aswadi will tell you more about what we can do from the diagnostics and what we can gain from the diagnostics. And then I think that's all from me. I'm going to show you our demonstration of our product, our ND9000, which is our smart positioner. In this video, we are going to show a quick demo on how our smart positioner works, its functionality and the features. As you can see here, this is our ND9000 mounted to our actuator and our butterfly valve. So as mentioned earlier, this smart positioner corresponds to 4 to 20 milliamp signal, and to simulate that current, we can use a process meter with 4 to 20 milliamp sourcing features. Now, we turn it on. And there you go, it is 4 milliamp, and it has already started up this display. This is the local user interface, or we call it LUI. From the screen, we can see the parameters measured by sensors built in this device. As you can see here, this is the position of the valve, which is in closed position 0%. This is the target position of 0%, the set point which is 4 milliamp, the actuator pressure difference, supply pressure, and the device temperature. Okay, before we proceed, we need to check the settings and the parameters of the ND9000 so that it is working accordingly to the valve and the actuator. In this smart valve controller, we can configure all of the required settings here, or we can do it remotely should it is being connected to a PC with our valve management software. And as you can see here, we can set the parameters. This is the parameter, the control performance, low cut-off, the signal direction, whether it is increasing to open or to close the valve, the valve type, whether it is rotary or linear, actuator type, fail action, valve rotary, and the dead angle. Okay, now I will show you how the valve with the valve controller correspond to the input signal. And for that, we are going to do a step test using this process meter. First of all, we need to make sure to always check on the valve controller pressure rating as well as the actuator pressure rating, and not to exceed the maximum pressure. And for this case, our ND supply pressure range is from 1.4 bar to 8 bar, and we are going to set the pressure regulator to 4 bar. We're going to set the supply pressure to 4 bar. Okay, 4 bar. And then we're going to do the step test. At 4 milliamp, the position is 0%. 8 milliamp at 25%. 12 milliamp at 50%. 16 milliamp at 75%. And 20 milliamp at 100%. We can also see the position at the screen here. I'm going to close the valve step by step. 16%, 50%, 25%, 0%. Smart positioners have the capability to perform self-diagnostics. I will show you what will happen if we cut off the supply pressure. We set it to 0, and the valve will start to close to its fail action. Okay, right now we are simulating a situation where if suddenly the supply pressure is not available, and the positioner will trigger an alarm and display the cause of the error on the screen. Okay, there you go. Supply pressure out of limit. For this case, an alarm will prompt a message of low supply pressure, and this will notify users to attend this problem immediately. Okay, that's all from me. Now for diagnostic part, Adi akan explain pasal diagnostic. Dengar baik-baik, ada quiz hadiah power punya. Bye-bye. So
Okay, hello guys. So today I will cover on the diagnostic features on our smart product, which is ND9000 series. So before we start further, let's recall on what yesterday my colleague Sim already shared with you guys on the structure of diagnostic. So diagnostic can be clarified into 3 generations. First generation is offline test. Well, the valve, actuator, and the positional condition is monitored by the diagnostic based on the tests performed during the startup and also the plant shutdown only. And the second one is a second generation diagnostic. The data can be collected from the valve assembly during the plant running. It also create the base for the predictive maintenance, as we can view the trend for the monitoring performance, counter diagnostic, and also the online diagnostic. And lastly is a third generation of diagnostic, where can guide us to troubleshoot when the alarm and the warning triggered on our positioner. So as you can see on the screen, this is the performance view of our software to evaluate the performance of the valve. So it's clearly to understand whether the equipment are healthy condition or not. Okay. So what the features that we got in our smart positioner? So some of them we can capture the life cycle of the diagnostic. So today I will cover about 3 only. So it's about the first one is a steady state deviation. So a steady state deviation is a historical look at the overall control accuracy of the valve, measured as the difference between the actual position and set point percentage. So what is possibility, the cost exclusion of the steady state deviation? First is about increase the valve or actuator friction, or second maybe leakage the actuator or the tubing. So what is maintenance that we need to do to make sure the steady state deviation is in acceptable range. So we need to perform the valve service and also the actuator service lah. And the second one is about a stable state load. So a stable state load means historical looks at the pneumatic pressure, which require to keep the valve in a stable position with a single acting actuator. This is the actuator spring force lah. So basically this is to for the double acting lah. So let's our actuator VPBI series. So what is the possible cost this stable state load can be changed? Is broken off spring lah. So we cannot notify because we need to open the actuator first, then we can see either the spring actually in a good position or not. And the third one is a spool valve position. So spool valve position is a historical look at the average position of the spool while the valve is fully stable. So what is the possible cause of spool valve position? So this means that the valve is not moving, but only spool valve in the positioner moving due to the maybe causing about actuator or tubing leak, or maybe after the calibration or change of the spool valve position can be changed a few percent without any installation problem lah. So we need to see lah the report, and also we can to interpret the data. So some of them maybe kita dah kena buat macam actuator servicing. Okay. So this is the online diagnostic that we have in our smart positioner lah. So we will cover about the device status, alarm limit, also event log. So the device status we can monitor all the performance of the valve, performance of the positioner, also performance of the actuator. So when you see on the screen, it shows on the green color, it means that the valve, all the equipment are healthy in a position. And we also can set a limit where to make sure our equipment are in a good healthy lah. So even log is one to storage, the event a warning when we do offline test. Also the every time the signal give to the questionnaire, it will capture in event log lah. So for the last topic is about the offline test lah. So for the online test, we have 4 type of online test in our questionnaire. First is a multi-point step, and the second one is a dynamic loop test, and third is a valve analysis test, and the lastly a valve deadband test. So what is offline test? So offline test is to evaluate the performance of the control valve, where the test can be performed by the device itself without change any input signal from the system. So bila kita nak buat offline test ni, so make sure lah. So the valve in and not in a process condition lah. So baru kita boleh buat, sebab says benda tu dia akan bergerak kan daripada 100% ke 0 ke 100% lah. So untuk buat calibration ataupun offline test semua lah. So untuk gambar pertama tu you boleh tengok lah. So this one is a multi-point test. So it actually sorry. So dah pukul 1.52. So Hanif, jom. So kita akan proceed dengan ni lah. So kita akan proceed dengan quiz.
Hadiah quiz hari ni limited edition Telkom shirt untuk TA 2020, TA nak tahun 2020 nak habis dah tapi boleh pakai buat Juni. Baik. Okey, soalannya ada sana.
Soalan dia wait ya. Wait ya. So soalan dia macam ni lah. So I cakap je. So make sure you dengar lah. So
Name one of the test.
name to the test for the offline test of our questionnaire. So you can start comment right now. So I will see on the screen.
Namakan 2 test dalam offline test yang Adi cakap tadi.
Okey, ulang balik. Okey, Zana, nampak je. So kita kita dah ada lah.
Nadia Zafira.
So Nadia dah cakap dah. So kita yang pertama adalah multi-point step test, and the second one is a dynamic loop test. So convert lah tu Nadia. So nanti PM kita orang, so kita orang akan bagi size lah untuk kamu ni. Oh banyak komen ni.
Nadia Zafira.
Nadia Zafira.
Okay, Nadia nanti DM PM kita punya digital marketing team atau boleh WhatsApp Adi je. I think that's all from us. Thank you for your attention, and don't forget tomorrow will be our last session on the flow control training. Will be presented by our managers Ivan, Sim and Najib. Bukan Najib asal dok. I think that's all from us. Okay. Thank you. Bye bye.